Welcome to the deep dive. Today we're tackling something, well, foundational. Concrete.
Literally the foundation of almost everything built.
Exactly. But not just any concrete. We're diving into a new additive called Graphene X. It sounds potentially game-changing.
It does.
Yeah.
Stronger, greener construction, maybe even cheaper in the long run. That's the promise anyway.
Right. So if you're interested in how we could build better, maybe more sustainably, stick around, this is kind of a shortcut to understanding a big potential shift in materials.
And we're basing this on a sales proposal we got our hands on from a company called Construction X.
Yep. So our mission today, figure out the real benefits, the science, the green angle, and, the cost implication.
Okay, let's start simple. What is Graphene X, according to this proposal?
Construction X calls it a patented, groundbreaking cement additive. The star ingredient is graphene.
Right, graphene, most people probably heard of. Super material, incredibly strong.
Yeah, the proposal throws out some numbers, like 200 times stronger than steel and 2.5 times harder than diamond, which is wild.
It really is.
Yeah.
But the problem's always been making it cheaply, right?
Yeah.
At scale.
Exactly. And that seems to be Construction X's big claim here. They say they have a patented, cost-effective manufacturing process.
Okay, so that's the potential breakthrough. Making graphene practical for concrete, finally. Not just a lab curiosity.
Yeah, unlocking all those properties. So let's talk benefits. The proposal lists quite a few. Strength and durability seem like the obvious place to start.
Definitely. They're talking a 30 to 35% increase in PSI, compressive strength.
And they give an example, right? Like standard 6,000 PSI concrete could jump
To over 7,800 PSI. That's what they suggest.
So what does that mean practically? Just longer lasting buildings? Or something more?
Well, longer lifespans, yes. Fewer structural failures, ideally. But it could also mean, maybe using less material for the same job. Or building differently. It opens up possibilities.
Less material. That links to the next point, doesn't it? Reduced rebar.
Exactly. If the concrete itself is much stronger.
You need less steel inside to reinforce it. Makes sense.
They put a number on it, potentially a 10% reduction in rebar. That's not insignificant cost-wise.
No, definitely not. Okay, what about thermal performance? They mentioned that too. Is that a major factor?
It can be. The proposal's a bit brief on it, but improved heat resistance, better heat dispersion.
So good for hot climates, fire safety, things like that.
Potentially, yeah. It could help with building energy efficiency in hot places, or add a safety margin where fire's a risk. It's another potential plus.
Okay, now this next one seems really interesting. Rebar protection.
Ah, yes.
Yeah.
This is pretty clever if it works as described. They say Graphene X forms a coating on the rebar, a protective layer.
Like a shield against rust.
Sort of, yeah. But it's apparently more active than that. They claim it actually removes CO2, which is often a catalyst for rust when it gets in with moisture.
Whoa, okay, so it's not just passive, it's actively fighting corrosion.
That's the idea. Preventing rust is huge for concrete longevity. It's often the weak link.
Very interesting. Okay, what else? Accelerated curing? Speeds up the process. Why is that good?
Time is money in construction, right? Faster curing means potentially finishing projects quicker.
Right, less labor time, maybe get the building operational sooner.
Exactly. And it could be really helpful in cold weather, where curing normally slows right down.
Okay, makes sense. Then there's improved flexibility. That sounds counterintuitive for concrete. Concrete's rigid.
Yeah, flexibility might be the wrong word. Think more like enhanced elasticity. Or maybe resilience to cracking.
Ah, okay. So it can bend just a tiny bit more before it breaks.
Something like that.
Yeah.
Concrete is brittle. If this makes it less prone to cracking under stress or minor movements, that's a big durability win. Less maintenance down the road.
Got it. Okay, now, the CO2 removal claim. This one really jumped out. The numbers seem huge.
They are striking. The proposal claims 90 to 95% CO2 removal from the concrete itself.
90 to 95%. Compared to what?
Well, they contrast it with what they say is the industry average for similar products, which is more like 32 to 45%.
Wow. Okay, that is a massive difference, if that's accurate.
If it's accurate and scalable, yes, it's potentially transformative for concrete's carbon footprint. Concrete production is a huge source of CO2 emissions globally.
So this isn't just about making stronger concrete, it's about making greener concrete in a big way.
That seems to be a major selling point. And they tie it into tracking, too. Emission offset tracking.
Right. Explain that a bit. What's a carbon offset for someone who doesn't know, and how does tracking help?
Sure. So a carbon offset is basically a certificate. It represents 1 metric ton of CO2, or equivalent greenhouse gas, that's been removed from the atmosphere or prevented from being emitted.
Okay.
And Construction X says they have a license to track and quantify these offsets when Graphene X is used, so they can generate green project reports.
Which are valuable because...
While regulations increasingly demand lower emissions, investors like green projects. It's good PR. It basically provides proof of the environmental benefit.
Okay, so performance, environment, and they can measure that environmental part. Let's talk money. Unmatched cost efficiency, $19 per pound. How does that stack up?
Well, they directly compare it to other graphene products, which they say are way more expensive, like $50 to $105 a pound.
So on the face of it, much cheaper than other graphene options.
Yes. But, and they do acknowledge this, the initial cost of concrete with Graphene X might still be higher than just plain old traditional concrete mix.
Right. The upfront cost per yard or whatever might be more.
Correct. But then they pivot to the long-term savings.
Which are? Let's list them again.
Okay, so potentially 10% less rebar needed. That's direct material cost saving.
Got it.
Longer lifespan of the structure itself, less maintenance, less need for replacement over decades. That's huge, potentially.
Okay, lifespan.
And then the potential to generate those carbon credits we just talked about.
Ah, right. So the CO2 removal isn't just good for the planet. It could actually generate income or offset costs.
Potentially, yes. If you generate tradable credits by using this greener concrete, that has real financial value in carbon markets.
Let's dig into that sustainability angle more. They call it a green concrete mix.
That's clearly central to their marketing. The CO2 reduction is the headline act there, lowering the carbon footprint of concrete.
And they use the term carbon sequestration. How does Graphene X actually do that chemically?
The idea, as presented, is that during the curing process, the graphene structure within the cement helps chemically bind CO2 molecules. It essentially traps them permanently within the solid concrete.
So it's locking CO2 away, not just avoiding emissions during production.
Exactly. Active capture and storage, sequestration. Which, if done at scale in something as ubiquitous as concrete, well, that's a big deal for climate mitigation strategies.
And just to be crystal clear on the carbon credits, again, define them simply.
Think of it like this. You do something good, like removing CO2 with Graphene X. You get a certificate proving you did it. Someone else who needs to reduce their emissions but finds it hard can buy that certificate from you to offset their own pollution.
Okay. So using Graphene X could let builders generate these certificates and sell them.
That's the potential framework, yes. It creates a financial carrot for going green.
Interesting. Now, the proposal gets specific about Texas for a moment. It says there's no formal buy clean mandate there.
Right. No specific state law requiring low-carbon materials in public projects. Not yet, anyway.
But they still see opportunity.
Yes. They mentioned existing programs, like the State Energy Conservation Office, SECO. They support energy efficiency in public buildings.
And Graphene X could potentially help with that, maybe through better thermal performance.
Or just by being part of an overall green building approach that SECO might favor. Then there's the TCEQ, the Texas Commission on Environmental Quality.
What's their angle?
They focus on emissions reductions generally. So a product claiming massive CO2 reduction in concrete would certainly align with TCEQ's goals, even without a specific mandate.
Makes sense. They also mentioned resilience. That feels very relevant for Texas with hurricanes and extreme weather.
Absolutely. Stronger, more durable concrete means more resilient buildings and infrastructure. Think post-storm recovery.
And that helps with funding.
It can. Making a project more resilient can make it more attractive for federal money from FEMA, HUD, the Department of Transportation. Those agencies prioritize robustness, especially in disaster-prone areas.
So even without a Texas Buy Clean law, you've got SECO, TCEQ, federal resilience standards, multiple angles.
Exactly. And developers can just choose to use it anyway, right? To hit their own sustainability goals or differentiate themselves.
And the proposal notes that graphene additives are generally approved for green building programs already.
Yeah, they suggest the groundwork has been laid regulatory-wise for these kinds of materials at federal and state levels.
Okay, but how credible is all this? It sounds amazing, maybe too amazing. Does Graphene X have a track record? They say proven and certified technology.
That's crucial, isn't it? They claim it's based on 10 years of R&D, studies, testing, not just something whipped up last year.
And endorsements.
They mention EPA and DOE endorsements, Environmental Protection Agency and Department of Energy. If true, that adds significant credibility.
Okay, so for listeners whose interest is piqued, what's the call to action in the proposal?
Pretty straightforward. Contact them for more info or a custom quote. They give the name and email for the executive sales director, Lisa Jackson. mslizzajackson@gmail.com.
Right. So let's try and wrap this up. Our deep dive into this proposal suggests Graphene X could be, well, a pretty big step for concrete.
Definitely seems that way on paper. You've got major strength and durability boosts.
Potential rebar savings.
And that huge CO2 reduction claim, which is maybe the most eye-popping part.
All apparently at a competitive price, at least compared to other graphene products?
Yeah, that 90-95 per CO2 removal figure really sticks out compared to the 30s or 40s they cite for others. If that holds up in the real world, wow.
It really does make you pause and think, doesn't it? If materials like this become mainstream, what does that mean for construction?
Right. How does it change the economics, the lifespan of everything we build, the environmental impact?
It kind of forces you to consider how these fundamental material science advances could ripple outwards, reshaping whole industries, maybe even our cities.
It may be a question for you, the listener, to ponder. How does learning about something like Graphene X change how you view future construction or the challenge of building sustainably?
Definitely something to keep an eye on.